Okay, so the other topic in section 4.4 once again would be the logarithm equation. Okay, logarithmic equation. Okay. So the whole idea is we're trying to solve something like this. We're trying to solve for x. How would we solve something like this for x? Say log base 2, and then of x minus 4 and equals 5 or something like that. The point now is that these equations here involve logarithm functions, logarithm terms, and we would like to solve for x that satisfies the left-hand side equals the right-hand side. Okay. So now before I can actually introduce the basic methods to you, and there's only one method for all the logarithm equations. However, before I introduce this methods to you, let me recall. Now we recall that in class we discussed something like this. Now, remember on the day that we talked about how to convert between or how to rearrange between the exponential form and back to the logarithm form, or convert from an rewrite from a logarithm form back to an exponential form. We're going to take the exact same idea and incorporate that into these things. So now what I have here is say log base 2 of 5, for example, and that would be equal to a number, log base 2 of 8, for example. Okay, and that would be, now the calculation would show that equals 3, isn't it? Okay, but now if you notice into the anatomy of this number, now this little number 2 is the base. The number 8 here is what? The number 8 here is the number being taken log on, and the number 3 right here is the equals number on the right hand side. So we learn how to turn this equation here into an exponential equation that says 2 raised to the third power 3 equals 8. Okay? We learned how to do that a few days ago. And so now we're going to take this exact same idea right here, learning how to rearrange these three quantities in the equation, rearrange them into the exponential form so that we can completely stay away from the logarithm expressions. Okay, so now the real method, the only methods for solving logarithm equation would be like this. Okay, and the methods for that. The equations logarithms of any base of a quantity of an expressions. So what I'm having here is a lot of time we don't just simply have an x, we have one whole expression of x. Okay? What I have here is ordinarily a log any base of an expressions and equals to a number on the right hand side. So now this equation here, I call this form right here the ordinary. I call this the ordinary form. Now, if you look one more time carefully at this, what's so-called the ordinary form, what I'm seeing here is in front of the log, I have no other coefficients multiplied to it besides 1. And so here, what it says is just simply one logarithm of base A, whatever that A is, that base A could be. And then inside the parentheses here, it comes some sort of expressions involves x, and then equals to a number, singly one number on the right-hand side. This is what I call the ordinary form. We need to, whenever we have an equation, we need to bring our equation back to this ordinary form so that we can actually solve for the equation. Okay? So now, back to this problem. Any equation in this ordinary form can be rearranged. Okay? Rearrange to become, remember we took the idea that we learned earlier. So now A as the base raised to the power m and equals to the expressions that's trapped inside your logarithm function. So as soon as you can rearrange your equation into something like this, an exponential, and this is what we call the exponential equation. Okay? As long as we can find a way to rearrange our equation into the exponential form, then we are good to go. Okay? This equation here gives us an access into solving for x. Okay? And we can solve. exponential equation. Okay, and once again, in the coming example here, I am going to show you how this method is going to work, and it's going to be working just fine no matter how complicated your logarithm function, logarithm equation is going to look like. So now, this is my example number 3 for section 4.4. So my example 3, this, we would like to solve again. Solve, right. Okay. So now let's say I have log base 5 and believe me, you can think of any ugly looking expressions to put in here. Now for us to start here, let's say 2x minus 1, okay, equals, about 4 is not a good number, just simply 2 on the right hand side, okay? We don't want to keep the number too large here. So once again, I have my equations in ordinary form. A log, a base, whatever base it could be. We have an expressions inside the parentheses of right next to the log, and we have a one single number on the right hand side. And so this is what I call the ordinary form once again. The equation right at the beginning point is in the ordinary form. Right? So now to solve for this equation, I must be able to rearrange these quantities, the base, the expressions, and the number on the right hand side. I need to be able to rearrange those three quantities there into the exponential expressions. So what I have here is the base 5. I'm going to raise that to the number 2, which is the power on the right, which is the number on the right hand side from the right hand side of the previous equation, and now it equals to the expressions 2x minus 1. That's how I rearrange my equation. And at this point, please keep things simple. Now 5 squared equals 25 on the left hand side. The right hand side remains 2x minus 1. So now please tell me, this equation here is not that hard to solve it at all, isn't it? So to finish solving this equation here, everything is just simply we adding 1 to both sides, and yes, that gives me 2x, and it equals 26 on the left hand side, and then dividing both sides by 2 to solve for x. And now my x turned out to be x equals 13. Okay? The only critical step whenever you're solving, so this is critical, okay? What's so critical about this? Do not circle your answer just yet, because you need to check. So when I say need to check, basically checking is one of the required steps after you found your answer. So now, checking your answer here, I'm going to simply plug x equals 13 back into my starting equation. On the left side, wherever I see the x on both sides, I'm going to plug my answer x equals 13 into my original equation to make sure that the two sides are all equal to each other. So now, what I can see on the left hand side, I have a log base 5, and inside the log I have 2x, but the x is being substituted by 13, so I have 2 times 13 minus 1. And let's check if it really equals to 2 on the right hand side of the equation. So now what I can see here is that, now continuing further with the left hand side expressions, I have log base 5 times, log base 5 of 26 minus 1, and then it's probably not clear yet whether it's equal to 2, but now what I can see now is that 26 minus 1 equals 25. So what I'm having here is log base 5 of 25 equals 2. Now, isn't the answer become trivial now? So yes, as long as you can see the answer trivial, where you can check it, where you can put a check on that final checking statement right there, then now you can go back and circle your answer as we now checking the fact that x really is equals to 13. And that is how we solve a logarithm equation.